In the diagram, points B and C lie on AD. What is the value of x? This is 130 right here, so this obviously has got to be 50, since these angles together have to add up to 180. And similarly, this angle here is going to be 180 minus x. And then all the angles in a triangle add up to 180. So 50 plus that 180 minus x plus that 60 have to add up to 180. And when you solve this algebra, you get x equal to 110. What is the smallest positive integer that is a multiple of 2468? Really what they're asking for, I think, is the least common multiple of 2468. So I'm going to write them as powers. So 2 to the power of 1, 2 to the power of 2, 2 to the power of 1 times 3 to the power of 1, and then 2 to the power of 3. Now, with LCM questions, you have to think biggest. And I know that seems a bit counterintuitive, that least common multiple, you think biggest. But that's the way it is. So let me explain. So the first thing that you do is you look at the prime numbers. What prime numbers are we looking at? So in this case, the prime numbers are 2 and 3. So the LCM will be some power of 2 times some power of 3, because those are the only prime numbers up here. And then you think biggest. So you look at the biggest one. So for the power of 2, the biggest power of 2 in this is 2 to the power of 3. So that is what goes into the LCM. Now with 3, same thing. What is the biggest power of 3 up here? It's just 1. So that's what you put there. And that is the LCM. And that's going to be 8 times 3, which is 24. Suppose that y is equal to ax plus 1 minus a for some unknown number a. If x is 3, the value of y is 7. Then if x is 8, what is the value of y? Y is equal to ax plus 1 minus a. And then they've given you that when x is 3, y is 7. So plug those numbers in, and we get 7 is equal to 3a plus 1 minus a. So that basically means that 6 is equal to 2a, so a is 3. So now that we have solved for a, we can now go back and solve for whatever they want, which is y, I believe. So they're saying, what is y when x is 8? Okay, so y would be a, which is 3, times x, which is 8, plus 1 minus a, which is 3. So this looks to me like 24 minus 2, which is 22. An 8 by 6 grid is placed in the first quadrant with its edges along the axes as shown. A total of 32 squares in the grid are shaded. A line is drawn through 0, 0, and 8C, cutting the shaded region into 2 equal areas. What is the value of C? So, I don't know where C is, but I'm just going to make a guess. Let's just say it's somewhere here. Something like that. Okay, so they want you to figure out the value of C. Okay. Well, how many are there shaded? They're saying 32, right? And each of them is like a 1 by 1. So 1 by 1, which is 1 obviously, is the area of each of those shaded squares. So 32 would be an area of 32. So if that line divides the shaded area into 2 equal, then that means what's above will be 16 and what's below will be 16. So this triangle will have an area of 16. So 16 will be 1/2 base times height. And this point right here is 8c. So that means the base is 8 and the height is c. So 1/2 8 times c would be 16. There you go. There's the math. So 16 would be 4c, and therefore c would be 4. Okay. So I was pretty close. Or was I close? No, it wasn't really that close, but that's okay. C is 4, and that's what they wanted. A palindrome is a positive integer that is the same when read forwards or backwards. For example, 1331 is a palindrome. Determine the number of palindromes between 1,000 and 10,000 that are multiples of 6. X is therefore between 1,000 and 10,000. So X is greater than or equal to 1001 and less than or equal to 9999. So that means all of these numbers have 4 digits. So since it's a palindrome, it'll be of the form A, B, B, A, just like the musical group ABBA. And we have to use divisibility rules. And I'll get into that a little bit later. But first, let me just see what the powers of, multiples. Multiples of 6 are of, just trying to see what are the units digits. Because I don't think you're going to get odd units digits, but let me see. If you get into this range here, the first multiple of 6 is 1002. And then you just keep adding 6s, and then you get an idea of what sort of the units digits are. So let me just do that for a few until I get sort of a repeat going, because usually these kinds of numbers are going to repeat the units digit. And I think I already saw it repeating. Yeah. Okay, so I see the repeat. It's basically 28406 and then 28406, like that. Okay, so that means multiples of 6s will have a units digit of either 28406. So this guy is going to be either a 0, a 2, a 4, a 6, or an 8. Okay, so that's just what I thought. This can't be an odd number. But here's the thing. It can't be 0, because if it was 0, it wouldn't be a 4-digit number. So I guess my revised list is 2468. So that means all of these numbers are going to be of the form either 2BB2 or 4BB2 or 4. Why do I keep saying 2? And then 6BB6 and then 8BB6, like that. So all the numbers are going to be of that form that we are trying to find. Okay, so is there some easy way, or do I have to just go through this manually? It's a bit time consuming if you go through it manually. All right, that's fine. I'll just do it manually. I'm not sure if there's some simple way. Okay, so let's start with the 2BB2, and now is where we kind of talk about divisibility rules. Divisibility. Okay, a lot of I's there. Now, you guys know about divisibility rules, but in this question, we're really concentrating on divisibility rule for 6. If something is divisible by 6. If something is divisible by 6, it is divisible by 2, and also it's divisible by 3. Now, if it's divisible by 2, it just means that it's an even number, and all of these guys are even numbers, so that doesn't really help us. But this one is going to help us. If it's divisible by 3, that means that the sum of the digits is a multiple of 3. Sum of digits of that number is a multiple of 3. So that's what we're going to use. So let's go. So we got 2 plus B plus B plus 2, and that is 2B, 4 plus 2B. And this 4 plus 2B has to be a multiple of 3. And this is how we're going to figure out B. So, oh boy. So it obviously can't be 3 because B's got to be a positive number. So I think the lowest it could be is 6. So let's just write down our multiples of 3. And the highest, if B was 9, it would be 22. So that's the highest it could go. So let me just go up to 21. Okay, so 4 plus 2B is either 6, 9, 12, 15, 18, or 21. You guys can easily solve that. And when you solve it, you get the following answers. You get 1. I'm only listing integers because remember, these B's have to be integers. 4, no solution for an integer, and 7, and no solution. So that means, I'll list it up here. My B is either 1, 4, or 7, and therefore this 2BB2 is either 2, 1, 1, 2, 2442 or 2772. And there you go. We got 3. So this one is done. And similarly, you got to do it for this one, and this one. Now, I'll do for just one more because I really think that you guys can do it all. But I'll just do one more, and then you guys can do this one and this one. I'll just do the 4s. Okay. All right, so let's just do that one. Okay, so same thing, 4 plus b plus 4 has got to be a multiple of 3, and this is 8 plus 2b. And so this is going to be either, okay, so the lowest it could be is 8, so the lowest multiple is 9. So 9, 12, 15, 18. What's the highest? If b was 9, it would be what? 26. So we got to go up to 26 for multiples of 3. That's going to be 24. Okay, so then you solve this equation. 8 plus 2b is equal to either one of these. And the solutions would be, well, some of these are not going to give you anything. 2, nothing, 5, nothing, 8. Yeah. So that means that this 4b4 is either 4, hold on, let's see here. 4, 2, 2, 4, 4, 5, 5, 4, or 4, 8, 8, 4. So there we go. We get another, this one's done. And then similarly for the 6s, I'll let you guys do that. You get, let's see here, 6006, 6336, 6666, 6996. That would cover that one. And then finally the last one, which is 8s. If you do the same process, you get 8118, 8448, and 8778. So we have in total these 3, and then we have these 3, these 4, and these 3. So a grand total of 13. Note that 1/2 plus 1/3 plus 1/6 is 1. And 1/6 minus 1/7 is 1 over 6 times 7. And 1/2 plus 1/3 plus 1 over 7 is 1 over 42, which equals 1. Determine 1 triple xyz of positive integers with 1,000 less than x less than y less than y less than 2,000. And 1/2 plus 1 over 3 plus 1 over 7 plus 1 over x plus 1 over y plus 1 over z plus 1 over 45 is equal to 1. All right, so where do we go from here? Now, these guys up here, they have given for a reason. I'm not sure why. I'm assuming they gave them because they help us to figure out a triple that satisfies that. So otherwise, I don't see any reason why they would give us those 3 things. So let's see here. Let's... Oh boy. All right, well, let's start with this guy here, because that 1 over 6 minus 1 over 7 is over 1 over 6 times 7, right? So that makes me think that if you just put a letter n minus 1 over n plus 1, that it's going to be 1 over n times n plus 1. And you can do this manually, and I'm sure you will get that result. So that's equation 1. And I think that is what we're going to use. Yeah. And then I'm going to use it on this guy to somehow make it look like this. So let's see here. 1/2 plus 1/3 plus 1 over 7 plus 1 over 42 is equal to 1. Now this guy has a 45. If it had a 42, might have made our life a little bit easier, but it has a 45. But I think we're going to use this to make it a 45. So let's see here. So 1/2 plus 1/3 plus 1/7. Those guys don't change. But what I'm going to put in... What can I put in? I got to do some fancy algebra here. Utilizing this guy. So 1 over plus 1 over 42 minus... Let me think about this for a second. Well, actually, this 1 over 42 is already in there, so I'm not really adding that. Yeah, let me just put that in there to kind of show that I'm not really, so far I haven't done anything. Now I can start my fancy algebra. What I'm going to do is I'm going to add something, subtract something and then add it. So that's perfectly allowed since I haven't changed anything. Same thing with the 44s. And then I think that's how I'm going to be able to stick in the 45. And that all equals. And that equals 1, which is right up here. So that part is the same. Now, this is finally where we get to use that fancy algebra. If you notice, these guys can be grouped together. That guy and that guy. So when you do that, that actually makes it a situation that you can now utilize this rule that they sort of hinted at with this guy right up here. So 1 over n minus 1 over n plus 1 is equal to 1 over n times n plus 1. So this guy right here would basically be 1 over 42 times 43. Correct? Okay, similarly, that guy would be 1 over 43 times 44. And then these two would be 1 over 44 times 45. And then we have that 1 over 45, and that all equals 1. So hopefully that looks very, very similar to this up here. And then now let's just expand those numbers in the denominators. So far this is identical to what's up here. And then this guy, 1 over 42 times 43 is 1806. 1 over 43 times 44 is 1892. And 1 over 44 times 45 is 1980. And then we have that 1 over 45, and that equals 1. So there you go. So with a little bit of fancy algebra, we're able to figure out that that is my x, that is my y, and that is my z. So x, y, z, that triple is 1806, 1892, and 1980.